Hello, welcome back to Database Design Made Easy. It's already time for part 9, where we will cover 6th normal form. And to understand 6th normal form, we have to go back first to 5th normal form, where the rule was there shall be no join dependencies unless implied by a key. And I will admit, in the previous video I kinda talked over that last part of the requirement, and that's because this becomes really relevant here, because 6th normal form simply says there shall be no join dependencies, period, even when they are implied by a key. So to understand this difference, let's investigate what it means for a join dependency to be implied by a key. So we have a simple table once more in a universe of discourse related to conferences, where we have a list of all sessions with their topic, the presenter and the room. And in this universe of discourse, the session determines the topic, determines the presenter and determines the room. Those are the 3 functional dependencies we have here, which of course result in a key on the session column. Now, if we have those 3 functional dependencies, then we could equally well say, let's implement each of those functional dependencies in its own table. So we have one table for the functional dependency session determines topic, another one for session determines presenter, and of course, session determines room. This is one possible way to split the table on the left into smaller tables on the right. So for this to be a join dependency, we need to make the test of throwing away the table on the left hand side, joining the new tables back together, and what is the result? It is the original table. Always, guaranteed. And basically that is kind of obvious because, well, both the 3 tables on the right as well as the single table on the left implement the same set of 3 functional dependencies. So basically those functional dependencies, and hence the key on the session column, imply that we can make this split and not lose information when we join everything back together. So this join dependency was implied by a key. And in 5th normal form, that means the table on the left is okay. For 6th normal form, the table on the left would be a violation because the join dependency, even when it's implied by a key, is there. We don't want that in 6th normal form. So a 6th normal form schema needs to go to the 3 smaller tables on the right. Now at this point you might think that 6th normal form means that all tables have just 2 columns. That is not correct. The thing is, sometimes keys are composite. So this is basically the same example, but now when we checked for 1st normal form already, we realized that the track code and the session code are relevant on their own. So having a single column for track code and session code would be a violation of 1st normal form. It would not be atomic. We need to split it into 2 separate columns, as you see on the screen now. Other than that split, it's the same example we had before. And now, indeed, we can split this in the same 3 tables for a 6th normal form. We still have a join dependency. We still have 6th normal form. But now the 6th normal form version has tables with 3 columns. And that is basically the actual rule for 6th normal form. If you don't want to do the official rule of no join dependencies, you might also say for a design to be in 6th normal form, the table can have just at most 1 non-key column. Which of course with a composite key means that you still get more than 2 columns total. Now we have looked at a simple table and a more complex table with a composite key, but what about a table with more than 1 key? So you have 2 candidate or more candidate keys, one the primary, the rest is alternate keys. How does this work? Well, we still have the same functional dependencies where session determines the topic, the presenter and the room, but in this universe of discourse, the organizer of the conference wanted to host as many presenters as possible, and they did that by giving every presenter no more than 1 session, so that every session has a different presenter. A result of that additional functional requirement is that there are now also functional dependencies where presenter determines the session, the topic and the room, and hence this alternate key on the presenter column. Now we can still make the same split we made before. Nothing changes, except that in the table with session and presenter, there now also in the 6th normal form is a key on the presenter column, an alternate key. But because we have more functional dependencies in the original, in this universe of discourse, there are now also alternate representations. Instead of using session determines room as the basis for a table, I can use presenter determines room. And I can do the same for session determines topic or presenter determines topic. However, what I must not do is do both. So if I am tempted to represent both presenter determines room and session determines room in this universe of discourse where there is a one-on-one relationship between presenter and session, then I introduce a problem. Because in the now 4-table design on the right, I could change the location for BI205 to room 270. On the right-hand side, nothing is violated. But we have a weird situation now, because session BO205 is presented by Oliver Danish. Oliver Danish is in room 315. But everyone who wants to see session BI205 goes to room 270, where there is no presenter. This is not right. And in terms of normalization, how does this work? Would this still be 6th normal form? Well, no. This is not a valid decomposition of the original table. Because let's check, if we now join the 4 tables together, do we get back the original table? And it's already dotted and crossed out, so you know the answer, but let's look at why. And the answer to the why actually depends on how you join the tables together. Are you only going to join on the session and presenter columns? Or are you also going to join on the room column, which is common to 2 of the tables? If you include equality of the room columns in your join condition, then in the original table you lose an entire row of data. Suddenly session BI205 no longer exists, and hence it hasn't a topic, it is not in a room, and Oliver Danish has nothing to do anymore. Well, we don't want that. So let's join on just the presenter and the session and not look at the room. But if you do that join, then suddenly there are 2 sessions BO205, both presented by Oliver Danish, both on dashboards but in different rooms. And that means that we now actually violate both of the candidate keys that we had identified in the original table. So no matter how you choose it, how you choose to join the new tables together, you don't get back the original table. In this case, there is no join dependency. And that doesn't mean that we are not violating 6th normal form. That means we did an incorrect decomposition because we created 2 different versions of the same table, one with session as the column, one with presenter as the column, which is impossible if you have a one-on-one relationship between session and presenter. Okay, we talked about 6th normal form, but what I didn't touch on is why. I mean, all the previous normal forms, I could give you examples saying if you violate this normal form, then I can make this change in the table which violates a business rule. And that is, in my opinion, a pretty compelling argument to try to normalize your schema to that normal form. Here, I have so far not given any examples of something bad that can happen in 5th normal form but not in 6th normal form. The only example of something bad happening was of an incorrect decomposition. But with a correct decomposition, 5th normal form and 6th normal form are not really that different in what business rules they protect. 6th normal form doesn't protect any business rule that 5th normal form would allow to be violated. There is a different reason for 6th normal form, and that reason has to do with null values. So let's change the universe of discourse a bit, and as you see on the left, there are now some null values in the table. What this means is that we miss some information. We know that session AD205 is presented by Kent Verlarge and in room 315, but we don't know the topic for that session. That might be because we forgot to enter it. Or it might be because Kent Verlarge hasn't decided yet. We already decided to give her a speaking slot, but she still has to choose her topic. Or it might be because she's just freewheeling and not talking about a specific topic at all. I don't know why. I'd have to understand the universe of discourse for that. But what I do know is that the topic for session AD205 is not known at this time, so we represent that with a null. And in the same way, we know that we have a session AD207 on performance, but we don't know who presents it. And for session DBA 305, we know the presenter, but we know neither the topic nor the room. Now, with those changes in the population on the left-hand side, we have, of course, to make the corresponding changes on the right-hand side in the sixth normal form equivalent. But the correct way to change that is not to replace values with null there. If you look at the first row in the table for session and topic, no, let's say if you look at the second row for the table for session and topic, and now remember what I told you when we talked about fourth and fifth normal form, data in tables is actually information, is actually facts. The second row in that table represents the fact that session AD207 will cover the topic of performance. Now if you go one row back up, what we have there is not the fact that session AD205 covers the topic of, well, I don't know. It's simply the absence of a fact. We don't have any fact, we don't know any fact about the topic covered by session AD205. And hence we don't represent those rows at all. So in sixth normal form, the same data would be represented like this. And that is, according to some people in the theoretical database world, a big benefit, because now we do not store any nulls. And as I said, there are people, did I say it? Anyway, there are people in the database world who dislike the concept of null. Now, frankly, I think they are wrong, but that is not in scope for this video, so let's not go there. What matters more to me is that once you start using this data in your queries, you probably have to join them together, and that has to be outer joins now so that you don't lose your data, your rows. And after those outer joins, you still have those nulls. So yeah, sixth normal form prevents nulls in storage, but it does not prevent nulls in your results or in your intermediate data. You still have to deal with null values, even though you don't store them. So I don't really see the benefit. Now, there are people who tell me, yeah, you get those nulls back when you join the data in SQL, in mainstream relational databases. But we at our university are working on a different relational database system with a different query language that uses special semantics, and we avoid using nulls. Okay, I get that. That can be an interesting research topic. But I get paid by my boss or by my client to work with mainstream relational database systems using SQL. So I, in my work environment, see no benefit at all to sixth normal form. You get the nulls back anyway, because missing data is simply a effect of reality. It's a reality of life. Sometimes data is missing. You have to deal with that. You have to represent that in some way. And yeah, null has its issues, but every other way to represent missing data will have the same issues, because it's basically missing data that has issues. And missing data is a reality of life, so you still have to deal with those issues. Now, apart from the performance issues you will have in mainstream databases when you would actually use a sixth normal form design, you also have a problem that you actually lose some protection by the database and that you open up to some violations that fifth normal form would prevent you against. And that has to do with candidate keys or foreign keys on multiple columns, so composite alternate keys and composite foreign keys. So I changed the example slightly. Now we have the session, the topic, and the first name and last name of the presenter. So in this case, during first normal form checking, we realize that first name and last name are important by their own. We don't want to have a single column that we constantly have to split in its parts. So the correct design with atomic columns would be a first name and last name column together. And of course, in a fifth normal form design, this table is okay, and you can just implement a foreign key to the presenter's table, which will have a candidate key on, again, the combination of first name and last name. And if you don't want any presenter to have two or more sessions, you can still add a candidate key on the first name and last name column combined. So in fifth normal form, this is a very nice design for this universe of discourse. Now, if we apply the sixth normal form rules, then if we choose to split on session, you get again those three columns, those three tables, apologies. However, in the fifth normal form version, we have a candidate key on first name and last name combined. We also want that key enforced in sixth normal form, but yeah, we really cannot define a key on two columns that are not in the same table. And similar for the foreign key to the presenter's table, once more, we can't implement that because first name and last name in sixth normal form are now in two separate tables. Now in this case, we could have prevented that by splitting on first name and last name, but what if there's two composite candidate keys in a table? Then either choice will give you this problem. Or what if there is a composite foreign key on a combination of columns that is another candidate key? Then you can't split there. So there are universes of discourse where sixth normal form actually disallows you to enforce all the keys, all the alternate keys and foreign keys that you want because they are composite. Now, how bad is this? Yeah, this is where it gets bad again, because in the sixth normal form version of this design, I can update session AD205 to be presented by someone with last name Cornelis. This violates nothing in the sixth normal form. But if I make that same change on the left-hand side, you now see that AD205 is presented by Kendra Cornelis. But Kendra Cornelis doesn't exist in our presenters table. I mean, it's not visible on the slide, but you can imagine that there is no presenter with the name Kendra Cornelis. So this is data I don't want in my database. The fifth normal form design makes the database prevent this update. In the sixth normal form design, it would be allowed. And similarly, I could update session BI205 to be presented by someone with the last name James. And this is not a problem for the foreign key because we have an Oliver James, but as you see when I make the same change on the left-hand side, now Oliver James has two sessions, which violates the business rule, which is implemented by the key on first name and last name. In a fifth normal form design, the database would once more instantly reject this change as a violation on of the alternate key. In the sixth normal form design, the database will allow this. So even though sixth normal form has the benefit, and yeah, I say that in air quotes, of not having nulls in storage, it comes at the price of allowing violations of alternate keys and foreign keys that the database no longer can detect. Now, recently I was in a discussion with someone who said, sixth normal form, isn't that the same as columnar storage, like column store indexes or Parquet files or many other new developments that use columnar storage? And while it is similar, it is not the same. Sixth normal form for this table would be 3 smaller tables of 2 columns each. Columnar storage, if you look at the storage layer, is actually 4 collections of 1 column each. And the engine ties them together in the right way. So it is not the same even if you look at the implementation. But what is more important is the fact that this is an implementation choice. And why is that relevant? Because the whole relational model, including all rules for normalization and including the ANSI standard for SQL, all very explicitly describes the functional level. How it is implemented is completely left to the vendor of the database engine, is not anywhere described in the standard, in the model, and it doesn't play a role in normalization. So even when the implementation is column by column, we still look at the functional level, and in columnar databases, the functional level still has a table with multiple columns. So it looks the same, but it is not the same. This table on the left, even when implemented as columnar storage, violates sixth normal form. So let's recapture what we learned. Sixth normal form requires that the table is in fifth normal form, but then there also have to be no join dependencies that are implied by a key. The benefit of this is that in the stored data you will not have any nulls, but in a standard mainstream relational database system, you will get them back when you join the tables, so you still have to learn how to deal with the special logic that nulls impose on you. If you use some experimental other system, then you will probably have to deal with their way of handling missing data. And to me, the biggest downside of sixth normal form is that you lose the enforcement of some composite alternate keys or composite foreign keys, which to me is quite a big one. So for me personally, in my day-to-day job, I'm not talking about academics and their theoretical models. I won't say anything about that because that's not my job. But in my day-to-day job as a database professional working on relational databases, sixth normal form is not interesting. I will not use it. I normalize up to fifth normal form. But for the official definition, let's finish this video with the standard finish of every video I've done so far. The data model is in sixth normal form if every table is in sixth normal form, or oh wait, there is no higher normal form, so a data model is in sixth normal form if every table is in sixth normal form, period. And that concludes the coverage of sixth normal form. But it doesn't conclude this series yet. Even though there is no normal form that is higher than sixth normal form, there still are some normal forms left to cover. So if all goes well, then in January 2025, I will finish my video on optimal normal form. As always, if you can't wait, or if you want way more details, then check my 7.5-hour course on Pluralsight, which you can reach with the link that you see now on screen, and that will also be in the description below the video. That is it for today. Thanks for watching. Please like, subscribe and comment on this video, and please return here next month for the next video. My name is Hugo Cornelis. I thank you for watching. Goodbye.